Guys and girls, it's Noah time! Noah time!
Alright, let's get cracking. I want to go over complex graphs with you because what you did so far was really simple graphs. Okay, if I give you a graph like this, a simple parabola, and I said this was f of x. Graph the prime of that, please. So which means find f prime of x. Okay? And a lot of you did that through a simple method of saying, well, first we look for this slope of 0 right here. And then let's draw another grid right down so you can actually see where it is. The slope of 0, I put it here. Check. And then we look at a concept called using positive and negative slope. And notice the slope here, it's a negative slope. So if it's a negative slope and it's approaching 0, I can say that the line looks something like that. It's a negative slope and approaching 0. Okay. Then if I look at this, I know that slope is positive, and the steepness of each slope is getting steeper and steeper. So in reality, what's happening is you're increasing your slope value. So the reciprocal, sorry, the prime of that really is a line that goes like that. Easy. Okay. There's actually no tricks to this. But the issue now lies, what if I give you a graph that looks like this? I'm going to pause it. I'm going to change things up a bit. I'm going to make this a slightly curved right here, guys. So slightly curved, it's not sharp. Slightly curved here. There's a reason why I'm going to do that in a second. I'll answer that right now. See, so this really is x, f of x. So now some of you ask me, so what does this graph look like? I'm going to use the same techniques as I've been doing before, teaching you how to graph this. I find where it's 0. And notice in this case, it's tricky. My slope right from here to here is 0. That whole entire bar is 0. This whole entire bar is also 0. So which means when I graph this, I start with the where it's 0 first. And this whole entire thing, well, this whole entire piece from here to here is 0. So my slope, the f prime of x, is going to be this shape right here. That shape. Okay? Then from here to here, it's going to be this shape right here. So I'm just going to draw it in for you right here, because I start with the 0. Now, what I'm going to do is, there's this piece in the middle. What does that really look like? And that's where the issue lies. Okay, I'm going to write a few things down. Notice, does anyone actually have a guess first? What's the answer? Simran? Is it slope lines, vertical line, horizontal line? Why is it a horizontal line? Ah, see, look at this one. Slope is constant here. You have a constant slope. Constant slope. So if your slope is constant, which means my graph is going to be a simple line. Let's say the slope you found to be, notice, is negative. I'm going to give you an example. So I'm going to assume this is going to be -2. If my slope is -2, when I draw this, I go down to the bottom right here, and I'm going to where -2 is, so I'm going to call this -2, and I'm going to draw my line. It's saying this is the slope, is -2. So that's what is how you do these constant lines right here. Negative question.
What about the dots?
Oh, the dots? So good question. This I know to show you that this is a curve line right here. So you're going to put a closed dot right here. Closed dot. Okay. I'm going to show you where these dots are matter. So let's give you another question. And your book talks about this. And the best way to give you talk about this is, let's say if I give you this equation shape. Up here, down, here, like that. Okay. If I look at this, there's key things I look for. Number one, I look for this slope, which is 0, right here. So let's draw another grid. Slightly down. 0 occurs here. Okay. Just a little quick mark. I want you to go ahead and do the yellow piece. Then do the blue piece. But I want you to stop here, and I'll explain to you why. Take a minute, draw the... Look at this piece right here. I notice it's negative, so I'm going to start with the negative side. And it goes up. Goes up like that. Then I look at the next piece. It's also positive. It goes up like this. But here's a little... What happens here? Your book talks about this, but I'm not sure if anyone actually understands why. What happens at that point? Why is there no derivative? Why is there no derivative at sharp point? Question is, the book says here, your book by definition says it's undefined here. Undefined, which means there's no derivative. Undefined. The question is why? And this goes back to your understanding of what a slope and how this works. If I were to zoom in, watch what happened. And what a slope really, f prime really is, means I'm taking the tangent of each piece. So if I take the tangent of this, and if I take the tangent of here, notice one thing. Once I get to the sharp point, I have a vertical line. What is the slope of a vertical line? It's undefined. Because the slope of a vertical line is like, for example, x over 0, which is dne. And that's the reason why a sharp point has no derivative. That's the exact reason why. So once you get to here, to show that it has no derivative, we're going to put an open circle right there to show that it's undefined at that point. Now, do the next piece. By the way, there should be a horizontal line right here. And it curves nicely. Horizontal line. Go. If I look at the next piece, this purple piece right here, well, I'm going to break up this purple piece into this green piece and purple piece right here. Really, there's two parts to this. The green piece is going to be a simple 0. So we'll draw the line at 0 right here. 0. But now the question lies in this purple piece. Some of you think it's a straight line. It's fine. We're going to assume that it's not a straight line. It's not constant. So really, we're going to start somewhere from the negative side. Negative. Okay? And then what happened is, it goes negative and it slowly levels down to 0. Why is it open? Because it's undefined at this point. You have nothing here. And that is what your graph looks like. Now, if you assume this is a constant, a straight line, then it will be a horizontal line here and then jumps up again. That is called complex graphing. It's based on your understanding of what f prime looks like. But done. Topic 2. Topic 2. Topic 2 is called working with derivatives. Let's see, I give you a question like this. F of x equals to x squared plus 3x minus 1. Find f prime of x. I'm gonna pause it. I'm gonna time you. See who does it the fastest. Who actually has a stopwatch right now? I want to see how long it takes the fastest student to figure this out. Your time starts. If you do this, really a lot of you did lim as h approaches 0 of x plus h squared. In this one, I don't need to break it up. Why? Because they're all simple numbers to work with. And there's no square root, so I'll just keep it the way it is. Plus 3 times x plus h minus 1 minus x squared minus 3x minus 1 all over h. And if you did this correctly, you should get 2x plus 3. Simple. Fastest student in my class did that in about 1 minute by Paulo. Problem is, Mr. No, I've seen that before, so I know the answer. So, what if I give you something totally different to do? We're going to try this one more time. The fastest student in UBC can do this before I finish the question. That's how fast they can do it. And that was actually set by me back there 2-3 years ago. So, here's your question. F of x equals to, I got 99 problems, cube. Well, actually, no, that's too scary. Oh, I'll make it easier for you. 2x squared plus x plus 10. Your timer starts. If I work with this, again, fastest time this time was 50 seconds. And they said, Mr. I'm going to do the limit formula again. But in reality, if you use the limit formula, you're going to get this 9x squared plus 4x plus 1. Question is, how did they do it so fast where you guys are still working on it? What's the trick? Did anyone figure out the trick yet? I'm going to pause it and let. If I look at my question, here's a question. Let's write this down. Maybe if I write this down and separately, you can see the trick. The question was f of x equals to, I'm going to start with my first one, x squared plus 3x minus 1. The answer for the prime of that is 2x plus 3. F of x equals to 3x cubed plus 2x squared plus x. The answer to that was 9x squared plus 4x plus 1 plus 10. Let's see if you can figure out the pattern. So, a lot of you say, hey, the pattern is this. The pattern was, some of you said, let's take this 2 multiplied by the coefficient. And then we subtract 1. What you just did was something called the power rule. Power rule. The power rule states this. F of x equals to x to the power of n. F prime of x equals to nx times n minus 1 to the power of n minus 1, which is exactly what Ruby just explained to us. We're going to test your theory out to see if this is true or not. So remember that day when I had a supernode challenge with you? I was actually cheating. I was using this method to bypass all that while you're working away. While you're doing your limits, I was doing this in my head. I'm like, oh yeah. So when I give you that 20-second head start, I can give you a 5-minute head start and I still can beat you because I just cheated. And I used a shortcut called the power rule. While you're working with limits and doing 99 to the power x to the power 4, I actually just did simple calculations in my head. Okay? Try this one. F of x equals to, in your original challenge, I gave you 99x cubed plus 33 something like x squared minus 2x plus 1 million. Now some of you say, that looks complicated. I don't give a hoot about what number it is. Okay. Doesn't matter how big the number is. It is still The derivative of a constant will be a unique number. Figure this out. You should be able to do it in less than 30 seconds. You should be able to do it before I finish the question. 297? 297 x squared, keep going. Plus 66x, keep going. Minus 2. What about this 1 million? Plus 0. So it doesn't really matter about that 1 million. The derivative of any constant, write this down. F of x equals to c. C is a constant. F prime of x equals to 0. So the derivative of any constant is just a simple 0. Okay? That is correct. Easy. So all this time I was cheating and then when I say Homer, so you give us a 30-second head start? Yeah, I was kind of cheating. I actually had advantage. F of x, what if I give you this? In your quiz question, it was root x. I'm going to pause it, let you guys. With this, is square root can be think of as f of x equals to x to the power of 1/2 from grade 10. Now we use the power rule on this. If you use the power rule on this, you should be able to do this quick. 1/2 x to the power of negative 1/2. Okay? But you cannot leave your answer like this. You got to get rid of this negative exponent because we don't like that stuff. That becomes 1 over 2 times 1 over root x. Because the negative means 1 over and x to the power of 1/2. So this becomes 1 over 2 root x. Okay. So your quiz question today was f of x equals to x plus root x. Find the derivative of that. Oh, someone say, oh, so it's so easy now. So that really is good. 1 plus 1 over 2 root x. And that's actually what we did on the board. I was trying to calculate the answer.
Wait, can you explain that, the yellow thing?
Oh, the yellow part? Okay. So this goes back to the concept of negative exponents. Would you agree 9 to the power of negative 2, negative exponent means 1 over 9 squared. Agree? Because negative just means 1. Take the reciprocal of it. Now, watch what happens with this one. This becomes 1 over x to the power of 1/2. Agree? X to the power of 1/2 really is 1 over root x. That's where.
Why are you multiplying it with the other 1/2?
Because the power rule states, I bring this to the front, well, 1/2, x, then I subtract 1. So there's really a 1/2 here already. So this blue part is here. That's the reason why. Hi, question.
On the quiz, I could have just written 3 over 2 and I would have been right.
Yeah, you show some sort of work. Okay. So the answer here was, that's how I did this. So that's the trick to doing this. Your work. You get a chance to practice the power rule. You need to master the power rule before I start the real stuff tomorrow. Page 156. Numero 1 to 16. All. You should be able to master the power rule before I can start the next lesson. Without the power rule, you can't do this.